Hi everyone! In this lesson, I would like to discuss options and how they are used in the context of error handling. As a quick reminder, an option represents a value that may be missing. For example, if we have an option of string, it means we either have a string when the option is a sum, or nothing when the option is none. An option doesn't necessarily indicate an error. For instance, if we create a user record from a web form, we would usually encode all optional inputs with an option. In this case, having none only means that the user didn't specify some data. Option is often used in the output type of functions to indicate that the operation might fail. For example, if we have a list of integers 2, 3, 15, and 7, we can find an element bigger than 10, but there is none bigger than 20. Okay, so I propose that we jump straight to the exercises. Let's go to the file option exercises, located in the package exercises.errorhandling.option. For the first exercise, we are going to implement the method getAccountID, which takes a role and returns an option of account ID. A role is an enumeration, which is defined just above. It has three different types of value. 1. A reader who has read-only access for a single account. 2. An editor who has write access also for a single account. And 3. An admin who has unlimited access over all accounts. The goal of getAccountID is to extract the unique account ID associated with a role. The problem is that admins are not linked to a particular account. They have admin access over all accounts, which means that when we call getAccountID with an admin, we expect to get back none. So please pause the video and try to implement getAccountID. As usual, you can find a test in the corresponding test file. Okay, so let's implement it. So role is an enumeration, which means that we can pattern match exhaustively on it. So we can say if the role is a reader, let's return a sum of the account ID, so it is a success. Same if it is an editor also has an account ID, so we can return it. If it is an admin, it's not associated with a particular account ID, so we are going to return none. Now we don't use these two fields, so a good pattern is to use an underscore to really make it clear that these fields are useless for this particular function. Now let's enable the test, or I already done so, and let's run it. Yeah, it works. Cool, so quick refactoring we could do is, as you can see, the problem with this syntax when you pattern match on a case class is that the number of fields matters. So for example, if we were to add or remove fields from a reader, so let's say if we add an email address to the reader, now this pattern match will start to fail because it will say it expected 3 arguments, but it only found 2. Now, ideally, we want to make our functions as refactoring proof as possible. So we want that if people add or remove items from these case classes, we don't really want getAccountID to be affected. So one way to do this is to name, to use this syntax. So here we say X is a reader. So we want to pattern match on role and only care when if it's a reader, and if it is, we just give it a name. So now this variable is called X, or you can call it whatever you want. X is just nice because it's short. So, and now you can say x.accountID, so you use the account ID field of the value x. And we can do the same for editor. So you can say x is an editor in this branch of the pattern match. And in this case, we do this. Now, if I remove the email from this class, as you can see, getAccountID is not affected, which is what we want. Let's rerun the test to verify, yeah, it all works. Okay, so before we move on, let's move this function inside the trait. So because role is a trait, so we can very well put methods inside it. In this case, now we don't need an input parameter because we are going to call getAccountID on the current role, and we're going to use this instead. Now we'll need to refactor the test because now we don't need getAccountID here. We're going to call it on the object. So we're going to use an OOP syntax instead. I find it much nicer to use and also much nicer to discover because you can just say on your IDE, you say reader role.getAccountID. It's much easier to find out. So let's run the test to verify. It still works. Yes, it does. Next, we're going to implement the method getUserEmail here, which tries to find the email address for a particular user. So getUserEmail returns an option of email. Because a user may not exist, we are not guaranteed to find them inside the map. And even if they do exist, they may not have an email address because the field is optional. So I'll let you pause the video and try to implement getUserEmail. Okay, so users is a map, so we can use the method get on a map to look up an item by key. So we'll say user ID is a key. And as you can see, it's returned an option of user because the this key may not be present inside the map. Now, because option is an enumeration, we can use an exhaustive pattern match on this. Now we say, okay, what do we do if the user is not inside the map? If it is not, then we can't return an email. There is no user. And if there is a user, what do? Well, we return its email. So we do user.email, and this is optional, so it all works. Let's enable the test. Yeah, all good. So I think it's quite simple to understand. Now, the only problem is this branch of the pattern match. I don't really like when you have something like case none, none, or you basically map something with itself. And this, generally, when you're in a situation like this, it kind of points to the method flatMap. Because flatMap does exactly this. FlatMap lets us concentrate on the happy path, on the case where there is a data inside it. So we can say flatMap, this gives us access to the user, and then we do user.email. And if you want the case where it's none, it's handled automatically by flatMap. So let's run the test. Yeah, it still works. Now, when we have flatMap, this points to for comprehension, to something we've seen in the previous chapter. So what we could do instead, it's really up to you to decide which syntax you prefer. So with the for comprehension, it's a for loop with an extra yield keyword at the end. And then the first line of the for comprehension, we're going to extract the user. And the second line, we are going to extract the email. So this syntax is a little bit more verbose. Let's just verify if it still works. Yes, it does. Personally, I quite like this syntax, even though it is a bit more verbose. Because each line inside of the for comprehension describes a potential cause of failure. The first one indicates that we may not find a user in the map, and the second one shows that the user may not have an email address. So once you get used to this syntax, you can extract lots of information very quickly. Another advantage of for comprehensions is that they let us focus on the happy path. And if there is any failure along the way, then the for comprehension stops immediately and returns none. In that way, it's really similar to the logic we wrote for I/O. Okay, next, we're going to implement the function getAccountIDs, which takes a list of users and returns a list of unique account IDs associated with these users. So if the user is an editor, we know that there is an account ID. This is the method we implemented previously. Same with reader, while if it is an admin, there is no account ID. Which means that in this case, we just discard it. So if we call getAccountIDs with this list of users, we expect to get back 555 and 741 because we have 3 users with account IDs, but 2 of them have the same, so we want to remove the duplicates. So let you pause the video and give it a try. Okay, so users is a list. So what we want to do is to basically iterate over this list and extract the account ID for each one of them. So we can say, okay, here we have, we can use map for this. So we say, okay, we have a user. So we do user.role.get account ID. Get account ID is a function we just implemented that extracts the account ID if the user is an editor and a reader. Now, this gives us an option of account ID. We iterate over the list. So this means that at the moment we have a list of options of account ID. While what we want to get is a list of account ID. So we want that if the option is none, we want to discard the value. But if the option is a sum, we want to unwrap it. So one way to do this is to use the method collect. So collect allows us to specify which value we care for. So for example, here we say, okay, I only care when the option is a sum. So if the option is a sum, I have an account ID. And in this case, I want to unwrap it. And if the option is a none, we just, collect will just discard the value. So let's run the test to see if it works. So where we are here, we'll run this one. No, it doesn't. And what does it say? Oh yeah, so it's because we forgot to do the deduplication logic. At the moment, as you can see, we are returning 555, 555, and 741. So we are returning 555 twice. So actually what we would need to do here is to deduplicate the account IDs, and we can use the method distinct from list to do this. So distinct will just, if you have a list of int or a list of whatever, it just removes all the duplicates. Nice, so now it works. So collect does the job, and it's very good for more complex use cases, like if you want to collect some values inside of a complex enumeration, it's perfect. Now but in this case, we have something simpler available. When you have a list of options, you can use flatten to remove the nonce and unwrap the sum. And actually, you see that IntelliJ is making us a suggestion, and it says when you have map followed by flatten, you can replace it by flat map instead. So what we could do is to say, okay, let's take our list of users, let's flat map it to extract the account IDs, and then we use distinct to remove the duplicates, which I think with this syntax is very concise and very powerful. Great, so we've seen that when we have a bunch of options, it's quite simple to ignore all the failures. We only need to flatten the collection, which means that we unwrap the option if it's a sum and discard the option if it's a none. Next, we're going to implement check all emails, which takes a list of users, so the same, but it tries to extract all the users' email addresses. So it is a bit similar to the previous function, but this time we want to be more strict, meaning that if one or more email addresses are missing, we consider this entire operation to be a failure. For example, if we call check all emails for a list of users where all the users have an email address, then we get back some. However, if the emails field is missing for at least one user, then check all emails returns none. So please pause the video and try to implement this function. Okay, so there are a few ways to implement this function. What we could do is first start a bit in the same way as before. You could use user flat map and let's extract the emails. Now if we do this, we get back a list of emails. So let's give it a name and let's put a type just to help us. So emails is a list of email. Now the nice thing about flat map is that it removes all the none. But in this case, we want to know if it has removed values or not. Because if it has removed values, we want to return a none. So what we can do in this case is to compare the size of the input list with the size of the email list. If both of them are the same, then it means that no value has been removed, so we can return a sum. But if some inputs, if the size is not the same, then it means that some values were removed, and in this case we need to return none. So we can say users.length is equals to emails.length. If it is, then we can return a sum of emails. Otherwise, we return none. Yeah? Let's enable the test. So I think for this function we have two tests. We have one for the case where it's successful, one where it's a failure. Let's run it. It works. Now, so this code works, but at the moment it's not extremely efficient because we iterate over the list 1 once we flat map it, and length is also inefficient. We do like users.length, which also iterates over the entire input list. Same for the emails. Now, on top of that, I mean, it is inefficient, but also it's annoying to have to implement, ad hoc logic for a situation that seems to be relatively common, to verify if all items inside of the list are some or none. So ideally, we would want to have a function to cater for this generic use case. So let's go back to the beginning and say, okay, if we have a list of users, we can map over it to get the email. Now, if you look at the type of this expression, it's a list of option of email, while what we want is an option of list of email. So the types are almost the same. At the moment, the only issue is that we want the list to go inside and the option to go outside. So we want to kind of swap the type parameters. And we have seen in previous chapters that there is a method for this situation. It's called sequence. So I've defined it before. So sequence does exactly what we want. It takes a list of option of A. It doesn't matter if it's an email, an int, a string, it doesn't matter. It takes a list of option of A and return an option of list of A. And the option will only be a sum if all the options inside it are sum, and if there is at least one none, it returns none. So it means that if we had access to sequence, we could implement this function like this. And as we've seen before, sequence and traverse are very generic, so it makes sense to have some syntax for them, so some extension methods. So I've defined it for you here. So I've defined sequence and traverse as extension method for this specific use case. So it means that we could implement check all emails this way. And in fact, we also know that when there is map followed by sequence, we can implement it, we can replace it by traverse. It will be even shorter. So this will be the implementation of check all emails if we had traverse and sequence implemented. This means that now we're going to try to implement sequence ourselves. In practice, we don't do this. I mean, it would be nice if it was part of the standard library, but it isn't. But all functional libraries define it, like cat, Prelude, and others. So for today, we'll just implement them ourselves. But I will put below the video some code sample if we want to use sequence and traverse if you use cats or Prelude, for example. So for now, can you please pause the video and try to implement sequence if you haven't done it so. Okay, so to implement sequence, what we can do is that we can take our list of options and pattern match on it. We can do this because list is an enumeration, so we can pattern match exhaustively. Now, we have two cases, one where the list is empty, one where the list is non-empty. What should we do if the list is empty? Well, if the list is empty, I get it wrong quite often. I have the tendency to want to return none. But actually, it should be sum of nil, because if you look at the definition, it says that it should return none only if there is at least one value of type num is input. Now, if the input list is nil, there is no value inside it, so there is no value none inside it. Which means that in this case, if the list is empty, it's a success, and the return value is just nil. Now, what do we do? This is a complex case. If the list is not empty, well, head is an option of A, and next is a list of option of A. So if you want next as exactly the same type as the input value, so we could, if we want, call sequence on next, which will give us an option of list of A, and then head is an option of A. So we have an option of A and an option of list of A, and we want to combine them only if both of them are sum, which means we can use a for comprehension, flat map, but we can also use a method called zip. So zip takes another option and returns an option of a tuple of the two values, which means that then we can call map on this result and pattern match on this. We say, okay, Here is the first element, so let's call it value. And the second element is the tail. Now, what we want to do is to basically recombine these two values together by putting the value at the beginning of the list. Let's give it a try. So let's enable the test for sequence and let's run it. It will also run the test for check all emails because it uses traverse, which uses sequence. Yeah, it all passes. Now the only thing to keep in mind is you see this symbol here. It means that sequence is recursive. And indeed, we are calling sequence in this case. So when we have a function that is recursive, we need to verify that it is tail recursive to avoid like blowing, avoid having an exception when we call it with a large list. And it isn't because when we call the function recursively, we do something after. To have a method tail recursive, the recursion needs to be the last step in the recursion. This means that we have faced this kind of issues before. Instead of using a manual recursion, we can use fold left, which will handle the stack safety for us. So we can say options.foldLeft, and in this case, the first part of fold left is the first part of the pattern match, except that we need to be explicit with the type of this expression because there is currently an issue with regard to the type inference of fold left. And then here we have two parameters, state and option. Cool. And within this parenthesis, we are going to copy paste this code. Now we just need to replace the variables. So now instead of sequence.next, so instead of doing the recursive call ourselves, we'll let fold left do it for us. So this is state, and this is called option now. Now we need to remove the annotation because the function is not recursive anymore. And let's run the test. It fails, and what does it say? So at the moment, we expected a list of 1, 2, 3, and we got a list 3, 2, 1. So we got the values in the wrong order. And we got this issue before because actually, when we write the manual recursion, this state actually represents the tail of the list. But when we do fold left, this state represents the prefix of the list, so the values we have already seen. So it's very easy to get it wrong. I do it all the time. But in this case, it means that we need to add value at the end of the list in order to put them in the right order. And now it passes. Now we know that adding values at the end of the list is expensive. It's not efficient at all. So what we could do is prepend the value and then at the end reverse everything. This will be more efficient. And as you can see, it works. Now this code is quite horrible, but something interesting is that if we go back to I/O, it looks exactly the same as the code we implemented for sequence for I/O. You see, we do a fold left, we zip the thing, and then we pattern match and reverse at the end. So it's exactly the same code. This kind of indicates that there is a deep pattern behind it. And that's why we have functional libraries like Z or Prelude or CATS who capture this generic pattern. So they capture traverse and sequence for lists, for vectors, for options, for I/O, for many things. And then they let us use this pattern of sequence and traverse for all of this. So that's why I will put below the video some code samples that will show you how to use this. So in practice, we never want to implement sequence and traverse ourselves, but it is a good exercise to understand how it works. In summary, today we saw that an option is an enumeration with only two constructors, some and none. As a result, it's fairly straightforward to deconstruct an option using pattern matching and write logic based on these two statuses. However, when we have many options to combine, it's much more user-friendly to use a for comprehension or sequence. The only thing to be aware of is that both methods are short-circuiting, meaning that if any option inside a for comprehension or sequence is none, then the resulting option will be none. Instead, if we want to ignore failures, we can use flatten or flat map on a collection, which will discard all the nones. As you can see, option gives us all the tools to handle errors. We just need to pick up the one suitable for our use case. Now, the main limitation of option is that we don't have any information regarding the cause of the failure. For example, when we try to look up the email address of a user, it could have failed for two different reasons. Either the user didn't exist, or the user existed, but they had no email address. However, with option, the only thing we get back when something goes wrong is none. So we don't know what was the cause of the failure. In the next video, we'll try to fix this issue using another type called either. See you soon.